Hello, this is section 2.6 on absolute value equations, and we're going to be solving these. There's some things that you need to know because you have to know how to get this set up initially in order to solve correctly. Notice if it says if a is a positive number, then the absolute value of x equals a is equivalent to x equals a or x equals negative a. Now, hopefully this will make sense to you since it is absolute value. Remember, the definition of absolute value is the distance from zero on a number line. So how far is this number from zero on a number line? Well, in this case, y equals 15, y could be negative 15 or positive 15. Either one of those is going to give us the absolute value of 15, right? So the absolute value of negative 15 equals a positive 15. The absolute value of positive 15 equals positive 15. So we have to know to check for these two different solutions each time we set one of these up. Otherwise, you've only solved and got one of the solutions instead of both. And a common mistake is to just leave out one of them. Okay, the next thing is we have to isolate the absolute value part, right? This term 2x is in the absolute value. We need to isolate that. So first we add 6 to both sides, and then we take the absolute value of 2x equals 10, and we're going to set that up now as our two equations, right? So we will say this: 2x equals negative 10. Remember, I have to make the 10 negative for one of these, or 2x equals positive 10. And then we solve. Okay, now this part has to be first. You have to isolate or your solutions will not be correct. If you try to set this up before you isolate the absolute value, one answer will be correct and your second answer will not. That's another common mistake that students make. So isolate first. Okay, we're going to divide both sides by 2. And that leaves me with solutions of negative 5 and positive 5. Now you can write that as negative 5 comma 5. Let me write a must. Must be first. That makes more sense. All right, next. Once again, isolate the absolute value part of this equation, right? Wherever the bars are, we have to isolate that part. And so we're going to say the absolute value of 3z minus 2 equals negative 7. Now, we could go ahead and try to solve this one, but you'll see if you check your solutions, which actually it's a good idea to check your solutions to be on the safe side. But in this case, it's going to be a no solution because it's not possible for the absolute value of something to equal a negative number. Remember, the definition is the distance, which is positive. So this is a no solution because once I isolated my absolute value, I got this negative number, negative 7. And negative 7 is not going to work no matter how we solve this. We'll solve it and get some possible answers and possible solutions, but when we substitute them back in, they will not be equal to negative 7 because when we take the absolute value, it's always going to equal a positive. On MyMathLab, they often give you this option, right? The 0 with a kind of it looks like a 0 with a slash through it, and that is considered the empty set or no solution. Okay, so this equation already has the absolute value isolated. So we'll simply take 4m plus 5 and set that equal to negative 5, or 4m plus 5 equals positive 5. And then we're just solving these two equations, right? So we're going to subtract 5 on both sides, actually for both of these. And then I have 4m equals negative 10. In this case, I have 4m equals 0. And then I divide by that 4 to solve. So m is negative 10 over 4 is negative 5 halves. Don't forget you must always simplify fractions to lowest terms. If you don't, then your answer is technically equivalent, but it's not simplified. So it always has to be simplified if needed. On this side, I'm just dividing 0 by a 4. So my two solutions are negative 5 halves and 0. And remember, I said you can write these with just a comma in between. I believe on MyLab that's what happens, right? It has you put them in this way. Okay, next. So this one is kind of a different equation because it's equal to 0. And 0 is not positive or negative. Remember, 0 is that number between the negative numbers and the positive numbers. So we actually can only set this one up one time, and we only get one solution because of this 0. Okay, so we take it out of the absolute value bars. Remember, always take it out of the absolute value bars when it's time to solve. Subtract the 2, and then divide by 3 to solve. So my solution, and this time it's just one solution, is negative 2/3. Right? And then we have completed this solving. Okay, once again, set this up 2 times. So 8 minus 6c equals negative 1, or 8 minus 6c equals positive 1. Now, you're the one who has to remember this part, right? I have to set this equation up 2 times, or I'm going to have problems here, right? I'm not going to get all the solutions that are possible. The only exception to that is when it's equal to 0. Okay, so we subtract 8 on both sides. You don't have to solve these at the same time. I'll just go ahead and finish this one. All right, and I'm going to simplify that fraction. We do not need to write it as a mixed number. Mixed numbers in algebra are kind of frowned on. We don't really want it to be a mixed number. What happens here is they're both divisible by negative 3, so that leaves me with positive 3 halves, right? Because a negative divided by a negative, if only I could write that line a little better, is going to be positive. Okay, let's finish this one on this side. So now we have negative 6c equals negative 7. We're going to divide by negative 6. And so my second solution, which I forgot to switch my color there. My second solution is going to be a positive 7/6. And that's it. Now, you can always go back and check your answers. And just a reminder of how we check our answers. All right, let's do this. Our possible solutions, you go back to the original, right? And I'm going to substitute in 3 halves. So I'm checking the 3 halves first, right? And so I'm going to have 8 minus, you can look at this a couple of ways. If you just take negative 6 times 3, that's negative 18. Negative 18 divided by 2 is negative 9. So this says the absolute value of negative 1 equals 1, and that's true. And let's also check, oh, I don't have to write check out again, the 7/6. 6 times 7/6. So that is 8 minus, right? The 6 goes into 6 one time, so that's just minus 7. The absolute value of 1 equals 1. This is true. So you can see that it does check. Okay, next. Now, I think technically you could clear this fraction to begin with, but I prefer to go ahead and set it up into my equations, right? The two equations. Oh, I want to make that one my -4. And then 1 plus 3n over 4 equals +4. So to clear this fraction, I simply multiply by 4. We have one fraction, the denominator's 4. Multiplying by 4 eliminates and makes that just a 1, right? So this will be 1 plus 3n equals -16. And we're going to do that same thing for this equation, right? Multiply by the 4. That just leaves me with a 1 both places here. So 1 plus 3n equals +16. And then we solve from there. So subtract 1 on both sides. I'm doing these kind of at the same time just to show you, you know, it ends up a little bit different with each one. Let's see, so that's 3n equals 15. So you can see one of these will end up as kind of a messy fraction, and the other one will end up as a nice whole number, right? So n equals -17/3 or 5. And those are our two solutions to this equation, this absolute value equation. Okay, so I'm going to stop this video and finish this lesson on the second video so it doesn't get too much longer.